Hey guys, welcome to the video for determining a function in continuous versus discrete. So this lesson is also kind of in two parts, but they do have to do with each other. So our essential question is, how do mathematical representations help us understand and describe relationships in the world around us? So to begin, we're going to talk about four different types of representations that we'll see when we're talking about functions. And remember, functions is something that for every input, there's at most one output. So our first representation is going to be tables. So if you want to draw like a little picture of a table over here, you may. Our second representation is graphs. So we're going to have a little x and y axis right there. We have a little graph. The third type of representation we'll see is ordered pairs, which are basically like coordinate points, so x comma y. Those are ordered pairs. And then the fourth representation is going to be mapping diagrams. Now, out of the four, if you haven't seen it, then it's probably the mapping diagrams is the one you probably haven't seen before. And it kind of looks like this. Sorry, I don't know what that voice was, but it looks a little bit more complicated than that, but that's kind of like the idea if you're trying to remember what they look like. So tables, graphs, ordered pairs, and mapping diagrams. I think I'm going to go ahead and split this video into two parts, go over just determining what functions are, and then the second video will be continuous and discrete functions. So, determine if the following tables are functions and justify your reasoning. So we're going into our first representation, which is tables. And so when I look at tables, what I'm looking for is I'm looking for repeating x values. I'm looking for x values that repeat more than once. So, for example, in the first table, so first of all, I have three tables. I have an XY table that's horizontal. I have an input-output table that's horizontal, and then I have an XY table down here that's vertical. But these are all the same thing. They're all still tables. Remember, input means X and output means Y, so really there's not really much difference going on with these three tables, just the numbers. So with this first table, you would read this as 1, 6, so like you'd have the point 1, 6, and then 2, 7, and so on and so on. But what I'm looking here is I'm looking for that every input there's at most one output, which means I'm looking for repeating x values. So out of the x values I have, 1, 2, 3, 4, and 5, do any of these repeat? No, none of them repeat, which means this is a function. So none of them repeat, so yes, it's a function. And it says to justify the reasoning, and the reasoning is that there's no repeating x values. Okay. The second table is we're still looking at the x values, so I'm looking. So if there are repeating x values, it's not a function. The only time it's a function is there's none of them. So my input, which are my x values, I have 1, 2, 3, 1, 6. Is this a function? No. The reason why this isn't a function is because I have repeating x values. I have an x value that goes twice, 1 and 1. It's repeating because 1's going to 5, but it's also going to 6. It's basically kind of like cheating. So if you want to think about it, you can't have your x values cheat. So your 1's can't go to two different numbers. One's going to 1, 5, and the other one's going to 6. Like, that's not going to work. So this is not a function because there are repeating x values, or one x value is repeating. As long as there's one that's repeating, it's automatically not a function. So next example. Looking at my x values, I have -1, 0, 1, 2. None of them repeat, so this is a function because there are no repeating x values. So no repeats, good. Repeats, bad, not a function. All right, so that's tables. So if we're asked to determine if something's a function, we might be given a table as our first representation. The second representation are graphs. So determine if the following graphs are functions and justify your reasoning. Okay, so the last one we were looking for repeating x values. Here, we're looking for, really we're wanting our graphs to pass a certain test. So the other test was x value test. This test is going to be, we are wanting to pass the vertical line test. And in middle school, your teacher might have called it the pencil test. The problem with the pencil test is that, well, can't you just hold your pencil like a multitude of different angles? Like I could hold it sideways like this, or I could hold it like to the side like this. So the pencil test doesn't really make sense. So we're in high school now, so we're going to use proper math vocabulary. The vertical line test is basically a line that goes up and down. It's a vertical line. If the function passes that test, then it's or if the graph passes that test, it's a function. If it fails the test, it's not a function. So the goal here, let me put that in blue. Goal can only pass through once. So if you draw a vertical line, your graph can only go through the vertical line once. If it goes through it more, then it is not okay. It fails, which means it's not a function. So let's go ahead and practice with the first one. So on the first graph here, I have like a diagonal line. If I draw a line here, is that a function still? How many times does it go through? Just once. What about here? Only once. What about here? Once. I can draw as many vertical lines as I want, but no matter what, every time I draw one, it only crosses once. So this is a function because it passes the vertical line test. And vertical line test is a bit to right, so I do allow VLT, so vertical line test. Just make sure you understand what VLT means. I'll just draw a bunch of lines there. Okay. The next one, let's draw a vertical line test. Does it pass? Yes. Does this pass? Yep. And this passes. So no matter how many vertical lines I draw anywhere on this graph, it passes. So this is a function because it passes the VLT. All right, moving on. Next part, we have one graph, it's a vertical line. So let's draw a vertical line. Does it pass? No, it fails really bad. That vertical line goes through literally every single point in your graph. So this fails. So this is not a function. It fails the VLT. All right, and this last one is different from the previous three graphs. The other three graphs are just lines, and this one is a bunch of dots. So we're going to go ahead and do the vertical line test. So for all these dots, you still have to do the vertical line test. You have to do it for each one. So this one passes. This one also passes. This passes. However, when I get to here, it fails, right? Because it's going through two dots at the same time. So it fails the vertical line test. So I don't even care that it passes the rest. I found an area where it messes up. So this is no, not a function. It fails the VLT. So you have to find one spot where it fails, and then it fails. So that is determining a function if we have graphs. So we have the vertical line test for this. So we've had two representations, tables, graphs, and now we're going to have ordered pairs. And remember, ordered pairs are just your little your coordinate points, which is x comma y. There we go. So for the first example, I have, what is going on with my iPad? Let's go. Sorry, I don't know what's going on. There we go. It wasn't zooming in. All right, so I have three ordered pairs in this first example. I have 1, 2, 3, 4, 5, 6. So just like the very first representation, we're going to be looking for repeating x values. Okay? So this first ordered pair is 1, 2. The x value is 1. Let's do this in a different color, actually. 1. Okay, the x value of the next one is 3, and the next x value is 5. So all of these x values are not repeating, they're not the same, so this is a function, no repeating x values. All right, the next example, we have 2 as our x value, 7 as our x value, and 5 as our x value. None of these x values are the same. So this is a function because there are no repeating x values. All right. I'm going to go ahead and finish this problem. I'm going to go back to the other two because I just thought of something and I think it's really important that you know. So for this one, I messed up. Can you change this point to 1, 1, please? All right, so let's make this black, actually. Black. and then we'll use baby blue. Oh, baby blue. All right, so let's look at our x values. We have 1, we have 2, and then we have 1. So this is not a function because we have repeating x values. We have a repeating 1. Repeating x value. All right, so just like the very first representation, we're looking for repeating x values. So I want to go back to this one, and I want to just do a brief example that we kind of isn't on there. So let's say I have 1, 2, 1, 3. Okay, so here I would ask, hey, is this a function? And you'd be like, well, let me look for repeating x values. So you're like, oh, okay. I have a 1 here, and I also have a 1 here. However, this one goes to 4, and this one also goes to 4. So is it really cheating? It's not cheating because it's going to the same number. So this is still, yes, a function, no repeating x values. Yes, it's repeating, but it's going to the same thing. So it's just like, hey, my name is Marco. Hey, my name is Marco. Like you're just repeating something over. So yes, the x is repeating, but it's not repeating going to a different y value. So it's still a function, right? The input still has only one output. The 1 still is only going to 4. Okay, and then for this second one, I wanted to give you a different kind of example because I feel like we should maybe talk about it. All right, so let me draw a graph in the middle, or actually on the side. I'm going to draw a graph over here. And then I'm going to draw a circle. And I'm going to ask you, is this a function? And you're just like, okay, well, let me use a vertical line test. Nope. Because it goes through this point and this point. So this is no, it fails the VLT. So you could have a different kind of problem where you have a circle, right? It might not be like a line or a bunch of points. It could be a circle or any type of shape. So if it crosses through the graph more than once, it fails the VLT. All right. And our very last representation is mapping diagrams. So we've gone through tables, graphs, ordered pairs, and now we're doing mapping diagrams. Here, you are also going to be looking for repeating x values. So you've learned two different tests. You've learned the vertical line test, and then you've learned the repeating x values test. So those are the two tests you use to determine if something's a function. And after we finish these two problems, I'm going to end the video, and I'm going to start the new video for continuous and discrete, just so that we can have two smaller videos instead of one giant one. All right, so we're going to determine if the following mapping diagrams are functions, and we're going to justify the reasoning. So the first mapping diagram over here, well, what does this mean? Well, where is 1 pointing to? 1 is pointing to 5. So if you're wanting to know what this means, it's saying 1 is going to 5, so I have an ordered pair 1, 5. 2 is going to 6, and 3 is going to 4. So I have 3 different ordered pairs here. And basically, we're still looking for repeating x values. So we don't want our x values going somewhere else. So does my 1, 2, or 3 go to multiple different y values? No. So this is a function. So yes, no repeating x values. Okay. And then on this next one, okay, let's look. We have 3 different x values here. And, well, 1 is going to 4 and also to 5. So sorry, there's someone at my door. Hello. Yeah, thank you. All right, so on this one, we have a mapping diagram still. And our 1 is actually going to 4 and 5. 2 is going to 5, and 3 is going to 6. So is this a function? No, because 1 is going to 4, but it's also going to 5. It can't go to 2 different things, so this is not a function. We have a repeating x value. 1 can't go to 2 separate things. X value. All right, that is the end for determining if something is a function. So we've gone through table, graph, ordered pairs, and mapping diagrams. Please let me know if you have any questions.